Hello, in this video I want to solve this limit problem. As you can see here, the limit of two expressions are given to us as x approaches to 3. And the thing is, these two limits include two unknown functions of f of x and g of x. And what question asks us to find is the derivative of y, where y is multiplication of f of x and g of x, the two unknown function here, at point x equal to 3. So the first thing that we can do is to see how is a derivative of y look like. So if based on the definition, derivative of multiplication of two function is derivative of the first function multiplied to the second function itself plus the first function itself multiplied to derivative of the second function. Okay, and if we want to know what is the derivative of y at point 3, we just substitute x by 3. X equals 3, and then y prime is derivative of f at point 3 multiply to j3, like the value of g at point 3, plus derivative like f of 3 multiplied by derivative of g at point 3. Okay, you can see here that in order to find out y prime, we need to know this for value, but we don't know what is f and what is g of x. So how we can find out this value? If we just go and look at the information that we have in the question and see if we can find out anything from that information. Okay, the first thing that we normally do in a limit is to substitute this value to the expression and see how the expression behave. Like here we have 3, so we insert 3 here, and okay, oh, this number which is 3 here, it makes denominator 0. So the expression is undefined as point 3. Undefined. But in the existing Khan Academy videos on limits, there are several examples of expressions that are undefined in this point, and we learned there how we can use factoring in the denominator, like in here, to simplify the problematic term and find out the limits of the expression in any other point that this problematic point. But the thing here is this limit exists and it's already been calculated. So the thing that we can conclude here that this nominator include this factor, and it's been simplified with this, and that's why we have this number here. So we assume that nominator is divisive and factorable to this term. So it should be look like this: x minus 3 multiplied with something. And what we can use here is we can assume that if nominator have this factor at point x equal to 3, the value for nominator would be 0, because you put 3 here and 3 minus 3 is 0. Yeah, so f of 3 minus 2 is 0. So somehow we did the other way around of what we did in other video of limits in the other video of Khan Academy. So you can guess that the situation should be the same here, like because like 3 minus 3 is also 0, and the expression is undefined as 0.3, so nominator here should include this term, and then it can be simplified with this and just make it possible that for this limit to be exist. So yeah, if this is this, so this nominator f x equals 3, nominator would be 0. Wow, and the good thing is from here you can see that you can find one of the value that we were looking for. Yeah, so we can find out what is f of 3 here, which is 2. Yeah, and also the same thing for j of 3. G of 3 is 1. Great. Yeah, okay. So this is g of 3 is 1 and f of 3 is 2. The only thing for us, the only thing left here for us to find is derivative of f at point 3 and derivative of g at point 3. One of the basic definition for f derivative of f at point x0 is f of x minus f of x0 over x minus x0 as x approaches to x0. And x, like this function can be any function, and x0 can be any point. So for that here x0 is 3, so we find what is f prime of 3. Prime of 3 is limits of f of x minus f of 3 so this definition is a basic definition for a derivative in a like math textbook, so that we just apply it here. So that should be limit of f of x minus f of 3. We already found f of 3, so this is 2, and this is x minus 3, where as x approaches to 3. Oh, the thing that we can observe here that this limit look exactly like this limit that is given in the question. So we already know the answer for this limit, which is 1. So f prime of 3 is 1. Yeah. Okay, we find the third value that we were looking for. So f prime of 3 is 1. And now we could do the same thing for the j prime of 3. the derivative of g at point 3. So the limit of g of x, like from here, the function is g here, and the g of 3 we already found it, which is 1 over x minus 3, where x approaches to 3. And this is also the same with this limit. So we already know the answer for this limit. This is 2. So j prime of 3 is 2. Okay, we found the last value that we were looking for. This one is also 2. Okay, so now we can calculate the derivative of y at point 3, and because we have all the values. So this is 1 multiplied by 1 plus 2 multiplied by 2, which is 5. Yeah, we have the final answer here. I hope you enjoyed this video, and looking forward to see you in the next presentation.